Hey guys, welcome to Spark Summit, and thanks for joining us. So we want to share our journey of building this platform. So today, my name is Satish, and I have Rohit with me to talk about the entire journey. So first, before diving into the actual technical details, I want to ask a simple question. Which one do you think is faster? Drinking a cup of coffee, like hot cup of coffee, or setting up an end-to-end data pipeline? So how many of you think like drinking a cup of coffee is faster? I believe like most of the, and then setting up data pipeline, it involves so many things like data ingestion, data processing, Kafka, Spark pipelines, deploying to production, those kind of things. So we did some internal survey like a year back. So today we're going to share from version 1.0 to version 2.0. So with 1.0, we survey some internal folks, what they think about the same question. So you can see on the top, on the left-hand side is 1.0, and right-hand side is 2.0. So 1.0, obviously 100% of people said that drinking coffee is far more easier than setting an end-to-end pipeline. And then on the right side, that's what we're going to share for the next 40 minutes, how we went from left-hand side to right side. So when we deployed this 2.0 with complete self-serve, we again surveyed, and they said, I mean, we are going there. We are not at 100%, but it's a good start. Like 70% said, setting up a pipeline is more easier than drinking a cup of coffee. So our goal, practically, we can't go to 100%, but closer to 100%. And then we surveyed internally all our platform engineers, the team engineers. And then, if you see before, they were spending a lot of time building these pipelines, managing these pipelines, whether this is big data streaming or AI inferencing, deep learning training, whatever. And with 2.0, the team is mainly focused on building platform tools, and we are giving this, empowering our tenants or users so that they can do self-serve. So enough of introduction. So I want to quickly talk about the agenda. So the first thing is who we are, like what we do at NVIDIA, what actually NVIDIA is doing recently. And then we'll talk about our journey from 1.0 to 2.0, which is left side to right side on that previous slide. And then what lessons we learn along the way. Mainly, we want to focus 3 S's: self-service, scalability, and security, and what we did during this journey. And there will be a small demo. Rohit will be showing setting up an end-to-end pipeline, hopefully faster than drinking a cup of coffee. So who we are, we provide a data platform as service for NVIDIA. We are kind of a central team. So think about NVIDIA is doing a lot of great stuff, and then they need a big data platform. So instead of every team having their own data platform, we serve the data platform as service for NVIDIA. So how many of you here are gamers, like GeForce, RTX? Okay. So NVIDIA is doing a lot of cloud side recently, in the last few years. So I'm going to, before diving deep into the entire technical details or how we set up, I want to give a brief context, what we are talking about today. So you can see there's some of the tenants that we support within NVIDIA. Like GeForce NOW is cloud gaming. It's how you play movies on Netflix. It's Netflix for games. So any recent AAA titles, you have a 10-year-old Mac or Windows or like super shitty laptop, you don't have a latest graphic cards, that's fine, you can play from the cloud. So it's like super complex because gaming is super complex, and then it's not like a movie. You need to be super interactive, you need to have like a millisecond latency, those kind of things. The second tenant we support is DriveSim. So NVIDIA is building the entire drive stack, like self-driving cars, like how you put self-driving car on a road. So DriveSim is basically simulation. So if you build a deep learning neural net, like DriveNet, so before putting your model on San Francisco busy streets, you can simulate. You can simulate day, time, weather conditions, stormy, super, snowy conditions like in Boston, New York. So you can pretty much simulate the entire condition. You can simulate some debris or load blocks on the road and see how your deep learning model is behaving. Is your car hitting someone else, or is it applying brake beforehand? So those kind of things. So the other tenant is AI smart cities. So it's AI for good, like how do we control traffic? And if you have garages, parking garages like malls, cinema halls, and then if someone is getting into a car, like how do you know? So immediately you need to know, okay, I parked my car in this garage, and if someone is breaking in, any anomalies, you get a text immediately. So what we do here, we do deep learning inside the CCTV cameras. Basically, we call a Jetson, those kind of things. It's all AI. Like we said, we do 2 things, like gaming and AI. So gaming is GeForce NOW running all AI. And the last thing is NGC, which is our cloud, NVIDIA GPU cloud. If you're a data scientist, you want super powerful machine, DGX1, DGX2, similar to how you rent CPU machines on AWS, here you can run GPU machines. Like you want to train a deep learning model, like for self-driving car or building a robot or building a smart city. So you can rent a container, like a Docker container with TensorFlow, all the latest Dockers with deep learning frameworks, and you can train your model. So enough of talk, like before we talk about all the things, we have a small video, thanks to NVIDIA creative team who provided us a video. So I'm gonna share a small video to give some context and how these teams are using our data platform to build these products, iterate at speed of light. So we're going to show the video in the same order. First, GeForce NOW Cloud Gaming, next self-driving simulation cars, next smart garages, which is Metropolis, doing AI for good for cities, and then finally Docker containers, how you run your machine learning, AI, deep learning, inferencing in cloud without buying this expensive super hardware. So these are some of the products NVIDIA is doing recently, and they all need a data platform to push out the products, understand, make decisions. So everything we do is data-driven. So every product that we ship, self-driving car, robotics, gaming, cloud gaming, anything, we go by data. So data is so much critical component of the entire the ecosystem. So with that said, so what's our data platform? At a high level, we need a real-time data platform powered by Spark, so that we need close to 30-second SLA, strict SLAs. And then as you can see, there are multiple tenants, but as they're growing, the data is growing. So we are seeing 1,000% increase in data. So you can see in the middle, the last 24 hours, the live dashboard, we processed close to 24 billion events. 2 years back, we were doing 1 billion events per day, which is a lot of data. But within 2 years, we've grown to close to 25 billion. As cloud gaming, self-driving, robotics, they improve that. We are going to, the target projected is around 50 billion to 100 billion this year, let alone just per day. So in a month, you're talking about 1 trillion events per month, and with less than 30-second SLA for people to make decisions, monitoring, analytics, whatever you talk about. So the SLA, there's a live 10-second, processing 24 billion, 95th percentile is 10 seconds. So the SLA we give is 30 seconds for all the end-to-end thing. And then on the right-hand side, it's like just a time series, like how many events we process. So we use this kind of a high-level dashboard. If anything goes wrong, we can see the SLA go into red section, or the time series drops, all those stuff. So today, we're going to talk about our journey from V1 to V2, like why that we even did with V2. So obviously, as you can think, like processing billions, tens of billions every day, and then processing 1 trillion events. So for every data pipeline, we need to set up, pre-processing, ETL processing, those kind of things. And let alone one team cannot handle everyone's needs because they have their own deadlines, and then it's super hard to serve all the needs unless we automate the entire process. So at high level, let me brief about 1.0, just for context, then we go to 2.0. So at high level, you have upstream and downstream. So that's the two key things that we always talk. Upstream is from source, which includes telemetry structured data and logs or unstructured data, pushing it to a gateway. So gateways are Kafka. Downstream is all the post-processing, like pre-processing, like ETL aggregations, merging, running Spark streaming jobs, and joining these 4 streams and then combine with something else. And so all the Spark pipelines and push it to output, like so that we can visualize on dashboards. So we use Spark dashboards, Spark streaming, batch Spark, and we use Elasticsearch a lot. So we like Kibana dashboards. We got used to Kibana from day one. So we need a good dashboarding tool, and we use Tableau also for SQL compliant. So the key takeaway, there's upstream and there's a downstream. So this is our 1.0 architecture. We reviewed this in a couple of older conferences like Strata and Elasticon. But if you see on the left-hand side, you have all the data sources, like structured, unstructured. In the middle, our platform is on AWS. That's how we could able to scale from 1 billion per day to 25 billion. And then you can see you have data ingestion layer, and then which is like our S3 or Kafka or API gateway, which gathers all the data from different sources. And then we have data processing, which is, as 1.0, it's not automated. I mean, not everyone can build a Spark pipeline because not everyone knows Spark in the company. So we need to set up all the ETL pipelines, merge it, and we do all the ETL processing. And we push one copy to Spark warehouse for long-term history or connecting or Tableau for reporting. And we push same copy to Elastic for short-term or Kibana dashboards. So there's one layer which does all the ETL or the data merges, those kind of things. And then some users use Kibana, some users Tableau. So the top 5 things, good things is scalability. It could able to, in the 2 years, it served more than 1 trillion events. And then the SLA is like 30 seconds for telemetry, like structured SDKs, and 5 minutes for unstructured. So the platform is hosted on AWS, so we get good high availability, all the goodies that you get with AWS, other than cost. And self-service, the moment we set up the pipeline, the data is in Spark or Elastic, then people can build dashboards. So that's the self-service we provide in 1.0. But we realized after some time that's not enough. Like people want to build their pipelines, but not everyone knows. If I ask someone learns Scala to build a Spark, no one is going to do that, unless you're a data engineer or a data scientist. Even data scientists like Python, not Scala. So V1 pipeline, just to summarize what we discussed so far. So we need a data. So making any data decisions, we need to collect data. And then we end up setting up a data ingestion pipeline and data processing pipeline. If you see, top is upstream, ingesting data to our gateway. On the bottom is ETL pipeline, like all the Spark jobs or merging data. And then once you have the data, the dashboards are not ready. Like you need to go and set up these dashboards. You need to go and set up these alerts. In most of the cases, we found out users build a dashboard, they forgot to build an alert, and they didn't get a production outage. So it's a manual effort for them who are build the self-service. It's not automated. So they need to build dashboards, alerts. And then we build a pipeline, we ship a pipeline, now party time, let's party, and then again, you get a new requirement, again, the cycle continues. So today, what if I told you we can automate this? That's what I'll talk about, how we are processing this, 10 different tenants, 4 is you saw GeForce NOW. How do we enable them so that they can be fast enough to ship their products? We have some of the greatest data scientists in the company. We don't want them to block on our team. We want to empower them. We want to give that scope to them. So in learnings, on self-service, we need to automate the data shippers, which is upstream. We need to automate downstream, which is setting up Spark without knowing Spark. And then we need to create zero engineering dashboards. You drop something, you have a dashboard. And you have an alert already set up. So you don't need to go back and do that again. And then finally, in 1.0, one of the big learning was the platform and applications are tightly coupled. So when we were building V1, the main intention was scaling. Can we scale 10 billion events per day? Can we scale 15 billion? But after that, we learned just not scaling. It's basically self-serve. People want to build their own things instead of we doing everyone's work. And scale, like I said, we are projected to go to 50 billion end of this year. As there is more self-driving, we are tying up with Tier 1 partners like Toyota and others. And then like every AI is like booming, so there's a lot of data. And then during this scaling section, we're going to share our learnings on, we hit some scaling issues, like for log parsing. Log parsing is one of the most important critical. You have telemetry data, you have logs data, you need to join this to make some decisions. So if your log is not scaling, then we can't meet the SLAs. That's how people complain, and then that's not a good thing. For security, for V1, it's completely secure. One of the things we learned is when we give data warehouse access to all these folks, they create some tokens using SQL Workbench or any SQL tools, and they start querying the data. But at some point, we want to tie up that security token to our LDAP. So as part of any compliance reasons, if you want to kick out some folks, like if you want to say that, okay, these folks can access non-personal data. These folks can access personal data. So when you go to the tenant and say, don't give access to these tokens, it's like hell. So instead of that, if you say that, okay, for this group or organization in this BU, just grant personal data access. For some, don't grant access. So all this is controlled by a new token management framework that built on top of Spark. We are going to demo that. And finally, billing. Some tenants want long retention. Some tenants want bigger clusters. Like some tenants have like 50-node clusters. Some has 500-node clusters. So they want a good auto-scaling, and they want flexibility. Some say that, okay, I'm willing to pay so much money, but keep my data for 1 year or 10 years or 7 years for HIPAA. So instead of having a strict same policies for everyone, we give flexibility, so they pay as they go, and then at the end of the month, they know how much they're using, and then we know who is using what and all those stuff. So moving on to 2.0, for 10K foot overview. So upstream, downstream, we automated with data bots, NV data bots, and downstream is NV data apps. Just for simplicity, during the presentation, I'm going to be calling, instead of data bots, bots, or apps, as NV data apps and apps are kind of interchangeable. The whole idea is you drop a bot, the bot knows how to ship your data from your source to gateway. And you drop an app, that's a default app, or some app, custom app, it knows how to process your data and put a dashboard. We're going to demo how we are doing that, but the whole self-serve is about dropping an app and a bot, and we need a good repository, like a central location, where every other tenant can share. If you're building an app or a bot for GeForce Cloud Gaming, most probably a self-driving car needs something in similar requirements. So instead of redoing the same work, we have a data market. Think about like an app store for Apple or Google Play Store. But we have a data market. We say that these are the sample bots or default bots. Just click, drop it, you get a dashboard, or you get the data. So in 2.0 architecture, like I said, just elaborating that, you have data bots. There are like, we use elastic beats components, and it has like hundreds of like open source community. If you drop something, it knows you have packet beat, you have a file beat, you have like network beat. There are like 100 different, every other company is like trying to contribute. There's a GPU beat. So beats knows how to ship your data. You don't need to do anything else. And then the platform is where our multi-tenancy. So for every tenant, we create clusters like Spark cluster, and then Elastic, data warehouse. And then the bots ships data to the gateway. And from gateway, we push to Kafka, and then we do ETL processing. So you can see the Spark logo. Those are our Spark apps, like NV Spark apps. And you can see, so what they do, they read data from Kafka, and then you can set up what you want to do. Like with a simple SQL query, you don't need to know Python or Scala. And the internal framework will package it as an app, and you can deploy to cluster. You can have 1 node to a 10,000 node cluster, NV scale. And obviously, we need a good repository. That's where we share across the company. Okay, these are the bots, these are the apps. You want some files, or you want some CPU utilization or GPU utilization, just drop this bit, drop this app, there you go, you get everything. So, and then obviously deployment is through Jenkins. You can define, and then Jenkins will take care of deploying the stuff. So just to summarize, there are 3 things we want to talk about: self-service, scalability, and security. So self-service is all about data bots and data apps. So data bots is basically, it does 5 things. One is config service. So if you say a bot, which is generalized, but when you say to each tenant, we need to have some context. So one tenant should not see data from other tenant because of security reasons. So every tenant defines their own config. Say that this is my path, and this is my software, and deploy this. The same thing, you have a single-click deployment, which we're going to talk about in the next slide. And then it has all the schema management, it has security, make sure one tenant should not push to other tenant data, and then monitoring, like which bots are working, which bots are failing. So what exactly is a bot? So bot is an elastic beat, like open source elastic beat, and then we add some YAML file. So YAML tells the context, like who you are, what you are pushing, those kind of things. And then there's a sample YAML. You can say, this is my logs, for example, file beat, and then this is my path. So anyone can define a config, and they can package a bot and deploy. So this is how it works. So on the left-hand side, we have a portal, and Rohit is going to demo that. So left-hand side, we have a portal. People can shop around, like bots, apps, and they can pick. We provide 2 deployment models. One is install only. You just copy-paste a script, deploy on any VM, you get a dashboard. This for the basic apps. We're going to talk about advanced apps. And the co-deploy, when you have thousands of machines running across multiple data centers, it's really hard to copy-paste. So we use co-deploy, and then say that you create a profile. Think of profile as like a plate, and it's like a buffet. If you go to buffet, you take a plate, and you pick whatever you want. Same concept. You have a profile, and you pick whatever you want, and say, give it the plate to deploy that. So you need to do all these things. All you need to do is like co-deploy mode, and then deploy the data. So the way profile works, this is a data market. There are hundreds of bots, assuming there are 4 here, and you define a config. What's the bot, what's the config you want, and then you define a profile. Profile is pick bots, pick config, and create a profile. Everything is automated, and with a single click, you can deploy to thousands of machines. Like you don't need to do anything. Like you just click, and that will take care of pushing data to Kafka. We don't need to get involved. So the second thing is data apps. Okay, now we solve the upstream. Now we need to solve the downstream. So downstream is more complicated because everyone has different requirements. Like people who want to write some Spark jobs. You need to maintain streaming clusters, which are like hundreds of nodes or thousands of nodes. So we cannot involve in deploying all these Spark jobs. So we built a framework, like a base framework, which we call NVData apps. So again, it has same config service. You define how many clusters you want. You define your code. Again, single-click deployment Jenkins. And then it has auto schema management, that's one of the challenges that we face. We're going to talk in the next. And you have zero engineering dashboards, and then monitoring, like how your Spark clusters are doing. Is it like 10 per second, million per second? You need to know if there is any lag, those kind of things. So there are 3 kind of apps. So during the journey, we talk with different tenants, and then one of the lesson was, the first requirement was, I want to drop something, I want a default dashboard with alerts, like CPU metrics, GPU utilization, network. If someone is hacking my data center, I want these default things. We cannot educate every single person and say, you need to drop this, you need to do this like this, then you get this dashboard. So instead of that, the first requirement people asked us, can we say drop something, can we get something out of the box? So basic app is all pass-through, it's out of the box, which Rohit is going to demo. So you have data, and then all you can say, data is coming to Kafka through bots, the default bots, and we provide these default apps in our data market. You deploy this app, and based on the scaling, it auto-scales and everything. And then if you see the config file, you just specify what's the app name, just some alias, and what's the output. You can push it to Elasticsearch, or you can push it to Spark Data Warehouse. The second app is intermediate app. So okay, basic defaults are fine. Not everyone needs like default dashboards like CPU, Apache, HA proxy, those kind of things. We need to empower users. Okay, I have Kafka. I have 10 different topics. Similar to GeForce Now, the moment you click a play button, the moment you start playing the game, it goes to different microservices. Every microservice push data to a Kafka topic, and they want a way where join by session ID do something, like aggregate, or what's the play time, whatever you see. So all they do is write a SQL query. Like they don't need to know Spark, Scala, or PySpark, those kind of things. All they define is a config. They write a SQL, and we have the basic framework, generic framework, and that will convert, bakes into that, and they can deploy. So this is a second requirement. People want to do self-serve. Like they start pushing the data. Now they want to do this Spark without knowing Spark. So that intermediate app will solve the problem. The third thing is advanced use case. Now I want to do some AI machine learning, like some inferencing, or I have a complex PySpark. Not everything can be done in a SQL query. So we provide this advanced capability where whoever knows PySpark or Scala, they can write. We provide notebook access. They can say commit the code to GitLab, and then they can have a set of the pipeline. The whole key takeaway, they don't need to know how to launch a cluster, run a cluster. The framework will take care of. All they need to know the SQL, or some advances PySpark. They don't need to worry about nuts and bolts, but they can do all this data magic and then get what they want to make business decisions. So let's just deep dive what challenge we face. So if you go back to just to context for basic dashboards, so we want a default dashboards, everything is good, but the problem is Spark streaming needs schema. As you all know, you can't expect Spark to do magic. You need to give schema. And when you have hundreds of bots, these schemas are complex nested JSONs. And Spark most probably don't understand. Or even if you understand, it drops some of the data. So one of the obvious questions is, if the bots is Elastic, Elastic has some default dashboards, why can't we use that? Obviously, the talk is unified analytics. We want everything to go to Spark and do some processing. A simple example, you're running a deep learning job on a particular node. And you want to join a job data and system data. Like, what's my utilization? For those kind of things, if you say, hey, for this system default, go to Elasticsearch, for this, go to Spark. I mean, people can't build self-service. So for that, we need to push everything to Spark, so through streaming. So that's our gateway. And from that, people can build whatever they want. So one of the challenge was Spark streaming needs schema, and then we cannot provide that. So what we did was, instead of inferring, we went with beats template. So you have a beats, you deploy into Elastic. It has a basic default template. We convert that to JSON. It creates a good level of JSON. And then we feed that to Spark, and you have a schema. And then we use that package as a basic app. So you have a basic app. We do some basic things like get the schema, package the schema, and then you drop the app, you get the dashboard. And then it's completely automated. So for default dashboards, you have bot and app. Now for inferencing, this is where things get interesting. We don't treat AI inferencing different from streaming use cases. Everything is same because it's data. For AI inferencing, it's an advanced app. There are two stages. One is you need to pre-process. You're getting millions of events. First you train a model, and then you put that model in Docker container. And then now the second step is into inferencing. The inferencing, when you get billions of events, you don't inference on every single event. If you're doing some anomaly detection, you read data from Kafka, you pre-aggregate, and you inference the 30-second output. So here, you just a mix of match. So first app, you write one Spark app, which is an intermediate app, which joins data from different Kafka topics, and push output to a new Kafka topic. And then you deploy second TensorFlow app, which talks to Docker containers, and then gives inferencing. So in short, people can mix and match. Like, one app, read, do processing, and push it back to Kafka topic. Second app, read from Kafka topic, does some inferencing. So they can do mix and match with these three categories. So now Rohit is going to talk about whatever we discussed so far. Rohit is going to demo how it works in real world.
Hey guys, I'm Rohit here. Thanks for joining our call today. So I'll be going over the demo. I'll be showing all the powerful self-serve capabilities that we built. And I'll be showing how easy we made it so that anyone in the company in NVIDIA who doesn't know Spark can just easily deploy bots and apps and get some default dashboards out of the box. So first, I'll be going over a basic app. So in a basic app, I'll be showing the install-only option. So install-only option is where you would paste some instructions into a VM and launch a VM. And then as soon as the VM launches, you just get out-of-the-box dashboards, or the data will start pushing to the upstream. And then secondly, I'll show the single-click deployment. So with single click, you specify your profile, you click deploy, and you can deploy with a single click to all your data centers, and you can start collecting all your logs with a single click. Then I'll show how to deploy an app. So I'll be showing a default Apache app and a default metric app, how you can deploy this using Jenkins and get out-of-the-box dashboard. So app is all the downstream. App equals all the ETL processing, the log parsing, as well as the out-of-the-box dashboard. We call them zero engineering dashboards. So one of the complaints in version 1 was that most people want to drop something and get out-of-the-box dashboards. They don't want to spend time writing dashboards. They have some default use cases like Apache, system metrics, HA proxy, Nginx, and they just want some default dashboards. They don't want to spend time building the dashboards. So I'll be going over how to deploy an app, which is the Spark app plus the dashboards. And then in the part 2, I'll be just quickly running through an intermediate app. I'll show how analysts use our SQL workbench. We use dbeaver. So how they use this dbeaver or any SQL workbench is JDBC compliant to run some SQL queries on the data. And then I'll be taking that SQL query and I'll just be deploying that as an app, and then they can build some custom dashboards in Kibana. So this is the exact profile I'll be deploying today. So this is the upstream part. So in upstream, you specify your configs. So there's a bot, file bot, and a metric bot that I'll be deploying. So the end user, all he needs to know is some alias and a list of file paths. So he can say, this is my logs A, which is my alias, and this is my HTTP, some Apache file path, and this is my metrics underscore A, which is my alias, and just a system. So just collect my system metrics. So, and then the profile is defined on the bottom. So profile, he can say, pick from all my bots and all the configs. So with these three things, he can just check this into GitLab and just deploy on Jenkins. And then it'll go to all the data centers, and the ingestion will kind of be set up all automatically. And then this is the downstream portion. So once again, you reuse the alias. So alias is kind of how we identify the pipeline. And then you specify the app. So here we say logs A, the app type is Apache, and just write to Elasticsearch. So with these three things, you get the ETL, all the parsing, you get auto-scaling Spark apps, and then you get out-of-the-box monitoring. I'll be going over all of that. And you also get out-of-the-box zero engineering dashboards. So I'll get started with the demo. So I check in all these configs into GitLab, and I just build. The build will validate everything, make sure all the configs are right, make sure the user's not doing anything wrong, and then it'll succeed if everything's good. And then this is our homepage. This is our data market. This is what most users are used to. They come here. They can see what configs they have. They can see what bots are available. So here you can see all the different bots, and then you can see some of the apps that we provide. So we have lots of different apps that we provide out of the box. And then here are the bots. So let's get started with the demo. I'll start with the install only option. So to install only, all you need to do is you just click install here, and then you pick your config. So I'll do a config demo, and you just copy your instructions. So here I have an EC2 launch wizard. So this is how you launch any EC2 instance for the first time. And then I have some instructions pasted on top. That's just so we dump some dummy logs, just so the dashboards kind of light up for the demo. So all I need to do is I just paste this in here. And then let's also deploy a metric bot as well. So I copy the instructions. I just paste them in here. And then all I need to do is just review and launch. So with the single, just copying and pasting, now the ingestion pipeline set up. The VM will launch. It'll run the commands that we set up. It'll set up the bots. It'll configure them. It'll do everything, and it'll start pushing to our upstream. And the second option is code deploy. So this is for single-click deployment. This is if you wanted to deploy a profile to a data center. So all you do is you would specify your profile name here, and then you just say deploy. So with a single click, I just specified my profile. I checked in some configs, a profile, and I just went to this Jenkins job. Every tenant has their own Jenkins job for deployment, and then just click deploy, profile name deploy. So now this profile, it'll take the file bot, metric bot, it'll deploy to all the VMs in the data center. You can choose where you want to deploy, and then it'll just start pushing data from all the VMs to upstream. So now we have upstream set up. So data's coming into the platform now, but now we want to visualize the data. So we need apps. So apps is the ETL processing, the downstream, plus the out-of-the-box dashboards. So let's deploy our apps. So similar thing for apps, you just have a Jenkins job. We just specify the two apps. This takes care of building the app, deploying the app. It launches this auto-scaling Spark cluster. It attaches that app to that Spark cluster, sets up the monitoring. It does everything out of the box. So I'm just going to build. So I ran this before the demo. Usually it takes around 5 minutes or so for the Spark cluster to start. So I already ran this before the demo for time constraints. And then, yeah, you can see the data starts coming into the dashboard. So this is the out-of-the-box Apache dashboard. So most people would want to see for all the Apache, there's some default metrics you want to look at, like what is my, where the calls API calls coming in from, what's my response codes, what's my error codes. All this stuff is like a default use case. So anyone has Apache logs, they want some default dashboard. So once they deploy app, it would deploy a ETL processing pipeline on a Spark cluster, and it also goes in and it deploys a dashboard. So you can just, we see the data coming in from our EC2, and our code deploy should also start coming in. And then similar thing, this is a metrics dashboard, so we see metrics data is coming in now. So this is all the CPU usage, memory, system load, disk usage, network traffic, all this stuff. So if we have a lot of data centers, and monitoring data centers is really important. So with a single click, we can monitor all the VMs on the data centers, and we can get like out-of-the-box dashboard. And then I'll just quickly run through an intermediate app. So people on the team, people in NVIDIA are used to SQL. They like SQL because it's very powerful. And they can do all sorts of joins, aggregates, anything complicated, window functions. They can do all this complicated stuff in SQL, which is not possible to do in Kibana. Kibana has a lot of restrictions, but SQL, we have fully SQL compliant. We use Spark SQL. So they get some token. I'll be talking more about tokens. But yeah, this is some telemetry data, some jobs, dummy jobs data that I set up for the demo. So they will write some query, and then the way that they'll do is they'll just take the query, they'll copy it from whenever they're done developing, or they'll create a view and copy the view, and then they just go to their Jenkins, and then they just paste the query in here, save it, and then they'll just take their app name, and then they'll reuse that same Jenkins job to deploy like a intermediate app. And then this is a custom dashboard that they can build on top of this. So this is like an intermediate app. So that's the demo, and then, so now you might be wondering, like, I have my pipeline set up, end-to-end pipeline. Now I need to monitor my bots, I need to monitor my apps. How do I know if my app is down? How do I know if my bot is down? So for that one, you don't need to do any additional work, you just get out-of-the-box monitoring. So every VM gets a bot manager. This bot manager keeps track of all the bots running on the VM, sends some health checks, all the stuff. And we can see like what's our end-to-end latency, and then how many bots are meeting SLA, how many are going over SLA. So we get alerts, we automate all the alerts and everything. And same thing on app side, we have app analytics, so you can see what's my throughput for my Spark apps, and what's my latency, end-to-end latency for my Spark apps. So if the latency goes up, or if the throughput goes up, then it auto-scales, and then we get alerts. So we get Slack alerts or text alerts, so that we can take some action. And then just to summarize everything, what we did today. So we wanted to collect some data. All you do is create a config and deploy with Jenkins. Setting up ingestion, before we had to manually set up ingestion, but now there's no need because it's already set up, it's already automated. Dashboard and alerts are also out of the box for all the basic apps. You don't need to do any additional work. And then pipeline monitoring, also available out of the box. And then hopefully we can take some vacation. And then I'll go over scalability. So we had to make 3 really big migrations for being able to get to the next 10x data growth, which we experienced in the last year. So the first big migration, we used to use logstash very heavily in the company, or in my team. And we used to use logstash for all the regular expression parsing, all the complicated log parsing, indexing to Elasticsearch. But we ran into 2 main problems. One is self-service. It's very complicated JSON parsing. No one wants to spend time writing or debugging a logstash config. It's really complicated, especially analysts you can't really ask them to do any kind of, write logstash config, so it's not really self-serve. And we're also hitting scaling limits on log parsing. All the complicated log parsing we're doing, we're seeing 2,000 records per second on a node. And with pass-through, just like direct pass-through, 10,000 records per second. So we're hitting some scaling limits, and there's no auto-scale available out of the box for logstash. So we switched to Spark Streaming. Spark Streaming has full SQL support, powerful regular expressions. So analysts can write SQL queries on their data. They can write regular expression. They can parse their custom logs, and then they can deploy this as an app. And then on auto-scaling, we also get auto-scaling out of the box since we use Databricks. And then here we can easily handle 10x a load. And then we saw almost 200,000 records per second on each node. So a big boost compared to logstash. And then another thing is Kafka connectors. So we were using a lot of Kafka connectors, and we switched over to Spark Streaming. Some of the things that we switched over were this S3 SQS source connector. We migrated to the SQS Spark connector. We wrote a custom Elasticsearch connector. We have used XPack, so for security reasons, we extended the Elasticsearch Spark. And then we switched from our S3, we used to use S3 Parquet sync connectors. We switched to Delta. So I'll go over more over what's Delta. So some of you must have heard about Delta. It's by Databricks Delta. So Delta is kind of like a data warehouse or like a layer, database layer on top of Parquet files. So it manages all the Parquet files underneath, and you can interact with Delta using Spark SQL. So before we were using Presto very heavily, and then this is how it was really kind of complicated. We had a Parquet sync connectors writing data into a live table. And then when people would query the data, they would get really bad performance because there's a lot of small Parquet files. And then we need Parquet files to be compacted and optimized. So query performance would go down. So we started an hourly Spark batch job where we would compact the data, we would create big Parquet files, and then we would write to a historic data table. And then we would manage partitions and create a view. So the latest hour data from the query goes to the live table, and the old historic data goes to the historic data table. So the end user doesn't know which table he's querying, but he just runs a query, and then our view would take care of that. But we ran into a lot of issues because it was a lot of heavy maintenance. Users' queries would get affected during the compaction jobs. You could easily corrupt the data because no strict schema checking, and a lot of manual management. It got kind of messy. So Delta kind of came to the rescue here. So with Delta, we get auto-optimized. So you can see the pipeline is a lot simplified. We don't need two separate levels, two separate tables. We just have a Spark streaming job writing to Delta table. And then you get fast ad hoc queries. We use SSDs for caching. And it's super fast schema management, partition management, all out of the box. And then for security side, some of the questions that we had, like who's accessing our data, who's our bad users, can we block them? They're probably affecting the query performance for all the other users. So we need to somehow automate all this stuff. So that's where we introduce our token management framework. So token management framework, the way it works is each tenant gets 3 DL groups. You have an admin group, general group, and a personal group. So a user will join a group, and then based on that, we give them permissions for the data. So first question, how do I get access to the data? So you just join a DL group, and then group admin will approve you. Once you're approved, our token management framework kicks in. It reads the DL groups, it detects any changes, and it automatically creates a SQL token, and then it assigns permissions on that token, and then it emails that token to the user, and the user can start using that token, and he can start querying his data in SQL. And then secondly, how to identify a bad user. So here as a part of token management framework, we built an audit dashboard so the admin can see what's my longest running queries, who's running bad queries on terabytes of data, affecting all the other users. And then he can either warn them or he can block them just by removing them from the DL group. And then I'll just hand back over to Satish to summarize what we just demoed.
Thanks, Rohit. So in summary, we build a lot of custom frameworks on top of Apache Spark or Databricks. So to provide the self-serve, in summary, on bot side, you have a default config service, you have a bot manager, a single click deployment. To drop something, you get something. Same thing with data apps. There is no ready out of the box analytics. So we built our own analytics for each Spark clusters. And when you drop an app, NV data app, now we know how many you're processing, those kind of things. And then Elasticsearch to Spark, like I said, everything goes to Spark, because we want to do some aggregations and everything, and we push back to Elasticsearch or Spark. So there is no direct XPack, a good connector, so we wrote our own custom connector to write from Spark to Elasticsearch. On the security, token management, like I said, you can have tokens, but after some time, when you have thousands of users, it's super hard to manage. Unless we natively integrate a token at a user email address at NVIDIA or DLs, then it becomes easy. So most of the compliance reasons, every quarter we need to say which users have access to my personal data. Can I kick them, some of them, if someone leaves the company, if their email becomes inactive, the token should be deactivated. So instead of we manually going through every quarter, the management framework will take care of that. So it's all integrated to LDAP, so that gives us more sleep. And then audit dashboard is where if someone is running a bad dashboard, like running last 10 years of data, and that might be breaking your Spark cluster, so we know immediately alerts, those kind of things. So those are the custom frameworks that we built that we could able to serve end-to-end. We could able to set up a pipeline less than 5 minutes, or we are giving power to our users so they can do their own custom things. So this is a team, special thanks to NVIDIA, and this is the team. The team has all the data scientists and data engineers. So mainly we do a lot of AI inferencing. So with this one pipeline, we could able to build streaming apps, batch apps, AI inferencing apps by mixing and matching these different apps for all our NVIDIA users. So that's all our talk is, like how do we self-serve faster than drinking a coffee.
All right.
Thank you.
All right, thanks, guys. We'll have a few minutes of questions. If anybody wants to ask a question, please come up to this mic and ask. Lunch is served. We are at time for sure, but these guys will hang around for a few minutes if you guys can ask questions.
This question about scalability primarily. So we have similar architecture. So how do you actually scale Kafka? That's first thing. And second thing, follow-up question is, when you have bots which are living outside, how they connect securely to the data pipelines?
Mm-hmm. So I'll start with the second question. So bots, when you deploy, and then we have a proxy. We don't expose Kafka to outside world. Kafka is within our VPC. So we need a good proxy, like a web service or something. And then all these bots push to a proxy. Proxy will make all the authentication, security mechanism, and it will make sure it is coming from the proper source. And if, let's say, some VMs got compromised, so we can deactivate a key So this we call a forwarder, bots forwarder or gateway. So it constantly syncs to our backend data source servers and say, is this token valid or not? So if it is invalid, then it will don't accept the data. Then once security is passed, then it will push to Kafka. So when you push to Kafka, so every tenant has their own topics. So when the bot pushes, we build a context in the config. And then when it comes to Kafka, so it will make sure we are getting the right data from the right tenants. So going back to the first question, how we scale Kafka. So for open source Kafka, we saw that you cannot simply auto-scale. I mean, you need to manually go and remove the partitions. Unless you pay a lot of dollars to Confluent, you don't have this auto-scaling capability with Kafka. So we always have some buffer, and we do some maintenance and make sure we have enough partitions are properly load balanced. So we wrote our custom partition load balancer for Kafka. So that will take care of, at every some interval, it will make sure all the partitions are balanced, and it will make sure the Kafka is scaling. But in short, if you don't want to do that, Confluent has a paid support, which is like they charge a lot of money, but we build our own custom Kafka auto-scaling groups.
Yes, good. So we actually have containers. Primarily, we deploy Spark, Kafka, and everything. So we're on Kubernetes. Have you guys tried anything on Kubernetes, like Delta, Spark Delta, or Spark streaming? Any kind of feedback on that?
Sure, that's a very good question. So most of our are VMs, but right now we're in the process of moving to Kubernetes. So probably next year we can come back and tell our experience, okay. how it works for auto-scaling, self-service on Kubernetes. But in short, frankly, we are just exploring how does it work. Because Spark, we haven't found an easy solution to deploy on Kubernetes at self-serve level.
Yeah, so one last question. You guys use Elasticsearch, right? So we have a time series data, we have an issue with the joins, and we have a Kibana, and primarily, we are actually moving to the data warehouse apart from Elasticsearch. Do you guys, is just like a practical question, do you guys still use Elasticsearch for powering your Kibana dashboards, or like do you have a Tableau and a data warehouse combination?
So this is our experience. Elasticsearch has some issues with scaling. It's hard to trust Elastic. I mean, Elastic is a great product, but after some scale, you cannot push 50 billion, 100 billion to Elastic and expect Elastic to work because it's a search engine. And number two, Elastic is not good at upserts. It's good at only inserts. If you want to update something, it will drop a record, create a new record. So it won't scale. So that's where we are losing sleep. So that's where we said, let's not push these billions to Elastic unless a tenant says that I want some aggregates. For log searches, Elastic is the best because of indexing and everything. And for analytics, joining and everything, only you do these aggregates, push an app. So that app reads from Kafka, does everything on Spark, and push a copy to Elastic. So most of our users, they use Tableau dashboards or JDBC. And who are use Kibana, we don't push these billions to Elastic. So we pre-aggregate and push that. But we had similar concerns with Elastic. Elastic, if it works great. It's kind of some black box, like if that doesn't work, if there is any delay. Going from 0.001 millisecond to 0.002 millisecond, we can't reach our SLAs. So we make sure Spark solved most of our problems, especially scaling. So Spark is kind of like a big brother over there, making sure it will handle those scale.
Okay, thank you. That's all.
Thank you.
Hi, can you talk a little bit about how do different apps share the data if they have dependency? So one app may be producing the data that other app wants to consume. I understood that you are spinning a new cluster, so you have a shared Kafka cluster where one app produces and the second one consumes from the output of the first one or something like that?
So that's a good question. So as we scale, we need to create tenant level clusters. That's where we create Kafka to a tenant and everything to a Kafka topics. So you have one app which reads from multiple topics and produces a second output topic. And you have a second app which just listen to the topic and do whatever logic you want to do. So instead of sharing a Kafka cluster across all the tenants, at some scale, it's better to make sure this Kafka cluster is for this tenant. Does it answer your question?
So like the first tenant is producing the output in the Kafka cluster of the second tenant who wants to consume that data?
Oh, so you're saying how one tenant shares other tenant.
Exactly.
So that's where our data warehouse comes into picture. In a streaming, we usually don't share, like GeForce NOW, they don't share with self-driving car division. Like mostly they have their own different data sets. They run into their thing. But think of it marketing, like they want to, like if you buy a GeForce graphic card, now you want to target, like cross-target and say, hey, you bought a graphic card, why don't you try this cloud gaming thing? Those kind of things, it's not through streaming. It's like, that's how we manage the token. So you get a token, that token you define a scope, saying that this token can read data from ARG1 or GeForce Now and self-driving cars. And then if you have the token, and then you can basically run some, it's all batch queries. So for these nightly jobs or targeting, those are batch queries, not streaming queries. But that will solve problem of how do we target, unify these users who are using different products, come under one umbrella.
Okay, yeah, otherwise in the absence of that, you will have everyone doing or starting from the very beginning, which causes a lot of duplication of the jobs.
Yes. Because mostly joining data across different BUs is mainly a marketing task, and then they don't need real-time streaming. They need some batch processing or like, 1 hour delay jobs. And that's how our Spark data warehouse comes into picture with Delta with token management.
Thank you.
Thanks.
Yeah, thank you for the presentation. I have a couple of questions.
Sure.
The first one is like the boat idea, that's pretty good. How do you handle the connection request or the config for different servers? For example, if you're reading data from SQL or Oracle or flat files or like logs, do you specify that for the config of the boat? And how does that part work, like the ingestion step? The second question is, when you set that up, and after a month or so, if schema changes, like will you create a new topic or new table on the backend or the downstream process? How do you handle that?
So you want to take the question?
Yeah. So if I understand correctly, you're asking how, like, if you want to collect some SQL like logs or metrics, or some like Cassandra or something like a different than like out of the something like that. That's the question, right? So what we showed in the demo was like a system metrics. So in the same metric bot, it also comes with different modules. So out of the box, you get MySQL, Cassandra, pretty much like Redis, like all the different systems. You can just, instead of system, if you just replace it with MySQL and deploy it, it knows out of the box that I need to collect MySQL from this particular, it knows how to collect that data out of the box. So that's pretty much like Beats takes care of that. We just, we take the config. So the config you see is just like a bare minimal config. When we deploy, what we actually do is we take that config and we add a lot of metadata to it. We add a lot of content to it. And then we push that to the VM. Then the VM configures it and starts pushing like Cassandra, MySQL, whatever you want to monitor, it pushes it out of the box. And on the schema side, we have a schema map. So if you're pushing MySQL, you just specify app is MySQL, and then it knows this is my MySQL fields. It knows a MySQL dashboard. So you get like, you can monitor all your different components with using these apps.
So one thing I want to add, we use schema registry, Kafka schema registry. For telemetry data, before what we were doing were, we would say that, okay, this is my new schema, push data based on the schema. So, but now with 2.0, what we did, when we have a tenant like GeForce Now, they manage their own schemas. And then when they want to add a new field, they check in a code. We have a schema generator, like you define as JSON or Avro file, and then we convert to a POJO. So we have a default generator, and they take the client library, jar file, so we get compile time verification, so that when they want to add a new field, they update the schema, they build a new, they run a Maven job, they get a new jar file, and they start pushing that. So we don't get involved in this, they manage their own schemas. But we provide a repository, Kafka schema registry, so all the Spark, every downstream process looks into the schema repository, download the schema. Same thing with bots. So if it goes to Elasticsearch, you don't need schema, but if it needs to go to Spark streaming, you need schema. That's where we mentioned, we did some hacks. So basically, push that to Elastic, take the template, convert it to a JSON where Spark understands, and infer the schema, and push that schema to schema registry. So whoever pushes the same bot, Spark understands.
Yeah, just to add on that question a bit, like if someone adds new field within that schema, like not at the very end, how do you handle it? Or the second part is like for that nested JSON, like it's very hard using Spark, like you have to process the JSON first and then apply schema. So how do you handle those nested structures within that JSON?
So you just shared our pain point in the learning. So nested JSON Spark is like, it's not super good. I mean, either it doesn't understand, even if it understands, lose data. So that's where we said, it's kind of for every app, we take that nested complex schema, we create Elastic dashboard. And when you create a template, Elastic will basically massage that, create a one-level JSON schema. And then we give that JSON schema to Spark. Now Spark understands that, and we say that, okay, for this default app, this is a schema. and we put in schema registry. So going forward, take for example GPU utilization bot. Going forward, we use the same schema. Unless we go to the next version, we don't have to touch that schema.
Got it. Thank you very much.
Hey guys, so I want to be respectful of folks' time. We're about 15 minutes over as we sit right now. If you guys want to hang out afterwards and answer a few more questions, that's completely up to you guys. But some of the technical team and some of us, lunch is ready, and we've got a limited time to get that done. So please ask some questions if you can, if you want to. But we do need to kind of shut up the room and the mics and all that kind of stuff, if that's all right. All right, I appreciate it, guys.
Thank you.
Thank you, guys.
Thank you, guys.